Hello class. In this first video, I'm going to show you how to graph polar equations on a polar grid and how to identify the equations. So on your top of page 2 of your note handout for section 5.2, we're going to graph the polar equation r equals 4. What is that? What does it look like? So first thing we're going to do is transform that polar equation to an equation in rectangular coordinates. To do that, we use the relationship between x and y and r and theta. And we know from section 5.1 that x is equal to r cosine theta and y is equal to r sine theta, right? For any point in polar coordinates, the corresponding x coordinate is equal to r cosine theta, the corresponding y coordinate is equal to r sine theta. And then we have the relationship x squared plus y squared is equal to r squared. So this first equation here we have in polar coordinates, we have r is equal to 4. And so you know I can square both sides of this equation. When I square both sides of the equation, I have r squared is equal to 4 squared. Well, 4 squared is 16. And we know from over here that r squared is equal to x squared plus y squared. So when I replace r squared with x squared plus y squared, you should immediately recognize that that's the equation of a circle. Where the center in the coordinate plane, the center is at the origin, and the radius is 4 units. Okay. So how do we typically graph in a polar grid? Well, once we have the equation in rectangular coordinates, we can superimpose a coordinate plane on the polar grid. Thusly, right, this is the x-axis, this is the y-axis. And so we graph this circle in the coordinate plane, and then we erase the x and y-axis, and then we know what this equation, this polar equation, looks like on a polar grid. So x squared plus y squared equals 16 squared is an equation of a circle with center at the origin with a radius of 4 units. So if the distance between each concentric circle is 1 unit, then starting here at the origin, I just go out 1, 2, 3, 4 circles to the right. Starting at the origin, I go up 1, 2, 4 circles up, then 4 circles to the left, and then 4 circles down, right? Plot those points. And then when I fit those points with a circle, you see that r equals 4, the circle r equals 4, is just the 4th concentric circle from the pole, from the center. And now I can erase the coordinate plane, the x and y axis. And now I know that r equals 4 is the equation of a circle with center at the pole. This is the equation of a circle of radius 4, and the center is at the pole in the polar grid. Okay? So that's the basic idea. Next, we want to graph the polar equation theta equals pi over 3. What on earth is that? Well, didn't mean to erase it, okay? But we have over here again, x is equal to r times cosine theta, y equals r times sine theta, x squared plus y squared is equal to r squared. And the fourth one that you know is tangent theta is equal to y over x. Okay. So this is our polar equation, theta is equal to pi over 3, right? So the angle theta is equal to the angle pi over 3 radians. So that means the tangent of the angle theta has to equal the tangent of the angle pi over 3 radians. Well, tangent theta is equal to y over x. And you know the tangent of pi over 3 from the unit circle is equal to the square root of 3. So if I now multiply both sides of this equation by x, I have y is equal to the square root of 3 times x. Well, that's the equation of a straight line that goes through the origin. Square root of 3 is the slope. And the y-intercept is 0. It goes through the, crosses the y-axis at y equals 0. So this is the equation of a line. Okay. So to graph theta equals pi over 3, right? We graph y equals square root of 3x in the coordinate plane superimposed on the polar grid. So here's my x-axis. Here's my y-axis. And now I graph the line y equals square root of 3x, right? Well, you know pi over 3 is the same as 60 degrees. And so when I graph y equals square root of 3x, the right half of the line occupies the ray 60 degrees, and the left half of the line occupies the ray 240 degrees. And so that's what the graph of y equals square root of 3x looks like. And so to get the graph on the polar, just on the polar grid, right, we erase our x and y axes. And now we know that's what the graph of theta equals pi over 3 looks like, okay? This is the equation of a line, okay, in the polar grid. Just occupies, that line occupies the ray 60 degrees and 240 degrees.